Alright, welcome to Unit 8.1. In this unit, we're going to quickly go over how to assign oxidation numbers, and we've been using oxidation numbers since October when we were writing formulas, but I just want to go over the official rules with you real quick. I'm going to try to make this video as short as possible. Alright, so the first rule that we have is that anything that is uncombined, I'll get a red pointer, anything that is uncombined, and when I say uncombined, I mean an element that's by itself, that is not with another element. For instance, let's say we have, get a red pen. Let's say we have silver. Silver is not in a compound. It's an element that is uncombined with anything else. So its oxidation number is going to be 0. Anytime, and this is a big rule because a lot of people keep missing this one. They keep thinking, oh, what's the oxidation number? It is, if it's not with anything else, its oxidation number is going to be 0. Now, if you have an element that is a ion already, so for instance, let's say you get copper. If you just see that copper with nothing up here in the upper right-hand corner, then the oxidation number is 0. But if you see copper with a +2 charge, then its oxidation number is +2. Alright, the second rule says any element that's in group 1 always has an oxidation number of +1, and anything that is in group 2, those are the alkali earth metals, always have an oxidation number of +2. Okay, and group 13 has a +3. So let's get a quick example of that. Let's say you have sodium chloride, NaCl. Well, we look here and we can see that sodium is a group 1 element, so that sodium must have a +1 charge. If we had magnesium chloride, we know that magnesium is a group 2 element, so it must have a +2 charge. If we look at aluminum chloride, aluminum is from group 13, it must have a +3 charge. So that takes care of number 2. Number 3, fluorine is always a -1. And it's because it's the most electronegative element, so it will always take an electron away from somebody else. So if we see like NaF, we know from rule number 2 that sodium is a +1, and we know that fluorine is a -1. Okay. Alright, the next rule number 4, is about hydrogen. Hydrogen is almost always a +1, except, big except, if it is with a metal. So let's say we have NaH, okay? Well, let's go back. Let's backtrack just a little bit. Let's do H2O. H2O, hydrogen is with a nonmetal. This is a nonmetal. And because it's with a nonmetal, hydrogen is a +1. If, however, we see hydrogen and it is with a metal, so let's say we have hydrogen, but now this time it's with an alkali metal, sodium, we know that sodium is a +1 charge because of rule number 2, that all group 1 elements have a +1 charge, then hydrogen must be a -1. And that's what it's saying right here. Okay? So right here, your example, lithium hydride, the hydrogen is a -1 because lithium is a metal. Alright, rule 5, oxygen is going to almost always be a -2. Okay, most of the time we're going to see oxygen being -2, so if I get a pen again and I write H2O, oxygen is going to be -2. We know hydrogen is almost always a +1, and so we have H2O. If, however, oxygen is in a peroxide, and there's a couple peroxides you probably should know. Na2O2, sodium peroxide, H2O2, hydrogen peroxide. If you have, or you see sodium peroxide or hydrogen peroxide, then the oxygen is going to be a -1 charge. Okay? Alright, rule 6. Most elements will be the charge on the periodic table. So look at your periodic table. The top number is always the most abundant of the charges. And then this one, 7, rule 7, all of the oxidation numbers that are in your compound must add to 0, unless it's a ion and then it adds to the charge of the ion. So let's say we're going to do one of these. Let me make this smaller. All right, let's say we take NO. All right, now if we look at our periodic table, nitrogen has a ton of charges to pick from. So I went ahead and I grabbed the periodic table to show you. So if you look here, there's lots and lots and lots of charges to choose from. I have no idea what number can be here. But I do know that oxygen, most of the time, is going to be a -2. We also know from rule number 7 that the sum of the oxidation numbers must be 0. So if this is a -2, if oxygen, I need a pointer, if oxygen is a -2 and there's one of them, and there's one nitrogen, then that number has to be a +2, because the sum of this number plus the sum of this number has to equal 0. So we'll write in N is going to be +2 and O is going to be -2. Let's try another one. Alright, I picked Na2SO4, so let's go through the rules that we know so far and let's see what we can find. We know that this element right here, sodium, is a group 1 metal. And group 1 metals, according to rule number, I don't remember what number it was, 2 maybe, are going to be a are going to be a +1 charge. So remember, group 1 is +1, group 2 is +2, group 13 is +3. We look at sulfur. Sulfur, like I said, has a charge of -2, +6, or +4. We don't know which one it's going to be yet, so we're going to keep that on the side. Now we look at oxygen. Let's change the color of the pen. We know because our rule says that oxygen is almost always a -2, except if it's in a peroxide, so we're going to put a -2 there. Now, this is the way that I think we should do this. On the bottom, you have subscript numbers. There's a 2, there's a 1, and there's a 4. Because of these subscript numbers, we are going to make ourselves a formula, knowing that the rule is that they all have to sum to 0. So this is what we're going to do. We're going to do the bottom number times the top number plus, and then we're going to do the next element. Bottom number, I'm going to abbreviate here, bottom number times top number plus bottom number times top number, okay? So when I say bottom number, I'm talking about the subscript, and I talk about the top number, I'm talking about the oxidation number. Okay, so we're going to go bottom times top plus bottom times top plus bottom times top till we run out of elements. So in this case, the sodium, which is our first element, is going to have a bottom number of 2. The top number is going to be plus 1. The next one is sulfur. The bottom number is 1. The top number we don't know. Plus the bottom number of the oxygen is 4. The subscript is 4 times the top number is -2. And we know the whole thing has to equal 0. So 2 times 1 is 2 plus 1x plus -8 equals 0. We can simplify this whole thing. 2 plus -8 plus 1x equals 0. We'll combine these things. We'll get -6 plus x equals 0. X equals +6. So now we know that this is the number that is going to be used for that sulfur, which is going to be right here. Okay? All right, so here's another example, getting a little bit more complicated now, because now we have a polyatomic ion, and this polyatomic ion, there are 2 of them in this compound. So let's do the same thing we did as in the last problem. Let's start with the calcium. We've got 3 calciums, that's the bottom number, times the top number. Now what's calcium? It's a group 2 metal, so we know from a rule that it is a +2 charge. Plus, phosphorus is our next element, so how many phosphorus do we have here? And this is where it gets tricky. It looks like there's 1, but actually there are 2 of them because this 2 distributes to this P. So we've got 2 phosphorus. Okay, so when I say bottom number, it's really the total number of those phosphorus. And we do not know what phosphorus is. Oh, say that 10 times fast. Phosphorus is this oxidation number is. That's what we're looking for. And then we have oxygen. How many oxygens are there? 8. And we know that because of the rule, oxygen is almost always a -2, except if it's in a peroxide, and this is not in a peroxide. And then the whole thing has to add up to 0. And we got 6 plus 2x minus 16 equals 0. 2x minus 10 equals 0. Whoops. 2x equals 10. X equals +5. So we now know that this phosphorus right here is a +5 oxidation number. All right, last example. In this example, we have a compound that is made of 2 polyatomic ions. And in these polyatomic ions, each one of these polyatomic ions has an element that we don't know what the oxidation number is. For this ammonium has a nitrogen, and this sulfate has a sulfur. And we don't know what the oxidation numbers are because when we take a look at nitrogen, you see all of, come back here. You see all of these charges you can pick from, and sulfur you have these 3 charges you can pick from. So what we're going to do is we're going to separate the ammonium and the sulfate into its individual polyatomic ions. So we know that the NH4 had a charge of +1. You can get that from table E, and we know that the SO4 has a charge of -2. Going back to our notes, if we look at Rule 7 again, we see that the sum of the oxidation numbers of a polyatomic ion must equal the charge on that ion. So this NH4, those elements need to add up to +1. And SO4 has to add up to -2. So we can do these individually and figure out what the charge of the nitrogen is and what the charge of the sulfate is. Let's start with the ammonium. So we're going to do the bottom number, which happens to be a 1, right? So we're going to do 1 times x, because I don't know what nitrogen's oxidation number is, plus the bottom number, which is 4, times the charge on that hydrogen. Now, this number right here is not the charge on the hydrogen. It is the charge on the entire ammonium ion. The charge on the hydrogen also happens to be a +1. That's not a pen. +1. Because of the rule that says all hydrogens have a +1 charge unless they're with a metal, and nitrogen is not a metal. So we're going to take this, we're going to make this a +1, so 4 times +1, and the whole thing needs to add needs to add up to this charge up here, which is +1, instead of adding to 0. We're going to get 1x plus 4 equals 1. And then we have x equals -3. And then we know that this nitrogen is going to have a -3 charge, and the hydrogen is going to have a +1 charge. Okay, now let's do the sulfate. Let's change the colors so that we don't get confused. Actually, you know what? Maybe I can be all fancy. Oh, I thought I could be fancy, but I can't be. Okay, we'll just write it over again. Ah, look at me. Fancy nonetheless. All right, let's do the SO4. Come here, pen. SO4 with a -2. Okay, we don't know the sulfur, so we're going to do the bottom number times the x, because we don't know. This is a 1, this is an x, plus 4 times what's oxygen's oxidation number? Oh, the rule says it's a -2, unless it's in a peroxide, which is not this case, equals a -2 charge. That -2 is right there, right? That's -2. So we get 1x minus 8 equals -2. X equals +6. So we know that S is going to be +6 and O is going to be -2 in SO4. Now we can put it all together, and we have, come here, NH4 to SO4. The nitrogen is going to be a +3. I lied, -3. Come on, Kaufman, get it together. -3. Hydrogen is going to be a +1. Sulfur is going to be a +6. Oxygen is going to be a -2. And we have this whole thing solved. Okay? All right, so watch out for those that have 2 polyatomic ions in them. And I hope this video helped you. And now let's get some practice done.